Hello grade 8 learners! For today, we will be discussing about the application of triangle congruence. At the end of this session, you will be able to apply triangle congruence to construct perpendicular lines and angle bisectors. Before we proceed with our discussion, let us first answer this activity. What is common in the four figures? Yes, each figure is composed of two lines which intersect each other. What makes figure 3 and 4 different from figure 1 and 2? That is right. Figure 3 and 4 illustrate perpendicularity. When we say perpendicularity, this means that the two lines intersect and form a 90-degree angle. Let us now proceed to the application of triangle congruence. First, we have the perpendicular bisector theorem and its converse. Perpendicular means two line segments, rays, lines, or any combination of those that meet at right angles. And bisector is an object, a line, a ray, or line segment that cuts another object, an angle, a line segment, into two equal parts. When these two words combine, it is equal to perpendicular bisector. And perpendicular bisector of a segment is a line, a ray, a segment, or plane that is perpendicular to the segment at its midpoint. Let us take a look at this example. Segment MP is a perpendicular bisector. M is the midpoint of segment ST. Segment SM is congruent to segment MT. Therefore, segment SM plus segment MT is congruent to segment ST. Let us now proceed to perpendicular bisector theorem. This states that if a point is on perpendicular bisector of a segment, then it is equidistant from the endpoint of the segment. That is, if line PM is perpendicular to segment AB and segment MA is congruent to segment MB, then segment PA is congruent to segment PB. On the other hand, we have converse of perpendicular bisector theorem. This states that if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. That is, if segment PA is congruent to segment PB, then line PD is perpendicular to segment AB and segment DA is congruent to segment DB. Let's have these examples. Number 1. Find the measure of segment PR. For the solution, segment MR is congruent to segment PR and segment MR measures 15 cm. Therefore, segment PR is equal also to 15 cm. Example number 2. Given that segment MH is equal to 30 cm, segment MA is equal to 15 cm, and segment HA is equal to 15 cm, which theorem would you use to find segment TH? The correct answer is the converse of perpendicular bisector theorem. Example number 3. Solve for the value of x. Segment MN measures 2x minus 3 and segment MO measures 5. For the solution, we have segment MN is congruent to segment MO. Substituting the values, we have segment MN is 2x minus 3 and segment MO is equal to 5. So 2x minus 3 is equal to 5. Combining similar terms, we have 2x is equal to 5 plus 3 by addition property of equality. 2x is equal to 5 plus 3 is 8. Divide both sides by 2. 2x divided by 2 is x, and 8 divided by 2 is 4. So the value of x is 4 units. Another application of triangle congruence is the angle bisector theorem and its converse. Angle bisector theorem states that if a point is on the bisector of an angle, then it is equidistant from the sides of the angle. If angle ABC is congruent to angle BPC, then segment AC is congruent to segment BC. For the converse of angle bisector theorem, if a point in the interior of an angle is equidistant from the sides of the angle, then it is on the bisector of the angle. That is, if segment AC is congruent to segment BC, then angle APC is congruent to angle BPC. For example number 1, find the measure of segment OR. If segment PO is equal to 12 centimeters. For the solution, we have segment PO is congruent to segment OR. Since segment PO is 12 centimeters, therefore, segment OR is also 12 centimeters. Example number 2. Find the measure of angle BRY given that the measure of angle URY is equal to 30 degrees. Applying the converse of the angle bisector theorem, we have the measure of angle BRY is equal to 1/2 the measure of angle URY. Substitute the given. We have measure of angle BRY is equal to 1/2 of 30 degrees. Therefore, the measure of angle BRY is 15 degrees. Example number 3. In the figure, line PT is the angle bisector of angle QPR. Find the measure of segment SR. By applying the angle bisector theorem, we have segment QS is congruent to segment SR. Substituting the given, we have segment QS is 3y minus 1 and segment SR is y plus 5. So we have 3y minus 1 equals y plus 5. Combining similar terms, we have now 3y minus y equals 5 plus 1. 3y minus y is 2y and 5 plus 1 is 6. Dividing both sides by 2, y now is equal to 3. Since the problem asks to find the measure of segment SR, we have now SR is equal to y plus 5. Substitute the value of y into 3. So SR is equal to 3 plus 5. And the final answer is 8 units. Thank you for watching.